Welcome to David Alexander Maths Tuition. This is chapter 12k, Modelling with Differentiation. So given that t is 65y to the negative 2, find the value of dt by dy when y is 7. Okay, so this one's actually not that bad at all. So if we want to find the value of dt dy, well, if t is 65y to the negative 2, then what is our equation for dt dy? Well, that's going to be negative 2 times by 65, so minus 130 y to the negative 3, which we could write as minus 130 over y cubed. Okay, so therefore the value, so when y is 7, dt by dy is simply negative 130 over 7 cubed, and that's all. We just need to chuck that into our calculator. Minus 130 divided by 7 cubed is minus 130 over 343, or minus 0.379 to 3 decimal places. Okay, so this is the sort of question where people might get stuck. So what do we need to do here? So it says, given that the volume v cubic centimetres of an expanding cylinder is related to its radius r, find the rate of change of volume with respect to radius at the instant when the radius is 10 and the height is 11. Okay, so the volume of a cylinder, let's just think, what is the volume of a cylinder? Well, that is pi r squared h. And it's also talking about the rate of change of volume with respect to radius. So if it's the rate of change, we need to be thinking differentiation. And if it's volume, if we say that the v is volume and r is radius, then the rate of change of volume with respect to radius, that is dv by dr. So all I need to do is differentiate this equation with respect to r. So that's going to be 2 pi r h. So dv by dr is 2 pi r h. So all we need to do is, well, what is the rate of change when the radius is 10 and the height is 11? Well, then the rate of change, which is the dv by dr, so this is the rate of volume with respect to radius, is going to be 2 times by pi times by 10 times by 11, so therefore dv by dr, so that is the rate of change of volume with respect to radius, where v is volume and r is radius, of course, is 2 multiplied by pi times 10 times 11, and that is 220 pi. So actually it's not too bad. It's just understanding that the rate of change of volume with respect to radius means that is dv by dr. So you'll need to somehow find it, or think of, we need an equation that's got r in it so I can differentiate. This question here is pretty much identical to the previous one. So the volume of a cylinder, pi r squared h. We want the rate of change of volume with respect to radius, so that's going to be dv by dr. So we're just differentiating this, so 2 pi r h. So what is the value, what is the rate of change when the height is 8 and the radius is 6? Well, therefore our dv by dr, that is going to be 2 multiplied by pi multiplied by the radius, which is 6, multiplied by 8, and therefore dv by dr, again that is the rate of change of volume with respect to radius, is going to be 2 times 6 times 8, which is 96 pi. Okay, so here's one final example. So a box in the shape of a cuboid is made from 32 centimetres squared of cardboard. Okay, so therefore the surface area is 32 square centimetres. The height of the box is x, and the opposite vertical faces are both square. Okay, so we've got a cuboid with a square at each end. So if I just do a quick sketch, it will look something like this. So we've got a square face at the front, so that is an x by x. Now we don't know the depth of the cuboid. This could be a multiple of x. They've not told us. It could be x plus 3, x plus 17. I don't know what it is in terms of x. I'd just be randomly guessing. So I'm just going to label this as y. Okay, now part A says show that the volume. Okay, right, show that the volume. Let's think about volume. What is the volume of this box? The volume is x times y, so that is x squared y. And we want to show that the volume is 8x minus 0.5x cubed. So how do I turn this y into some stuff that will turn it into an 8x minus 0.5x cubed? Well, the fact is we know that the surface area is 32, so let's play around with that. So this, the front face, that's an x squared, and there's going to be another one at the back. So the surface area is going to be 2x squared plus, now this face here is x times y, this is also an x times y, the one round the back is an x times y, and the bottom is an x times y, so that is 4xy, and that equals 32. So I've got another equation with a y in it. It's this y that's causing the problem. Okay, so what I'm going to do is I want to work out the volume, so if I can replace this y with some x stuff, I'm absolutely fine. So what I'm going to do is I am going to get this equation in terms of y. So first of all, 4xy is going to be 32 subtract the 2x squared. So therefore y is this divided by 4x. Okay, so all I need to do is substitute that in for y. So the volume is now x squared multiplied by 32 take 2x squared over 4x, and that is 32x squared minus 2x to the power of 4 over 4x, and dividing through by x and 4, that is going to be 8x minus 0.5x cubed. There we go, 8x minus 0.5x cubed. Okay, so we know that v is this stuff here, and we want to find, given that x can vary, we're going to use differentiation to find the maximum or minimum value. So if we're trying to find the maximum of this cubic function, we need to differentiate it. So this is going to be dv by dx, and that is going to be 8 minus 1.5x squared. Now the maximum or minimum means it's a turning point where the gradient is 0, so I'm going to set this to 0. So 8 minus 1.5x squared equals 0, so therefore 8 is 1.5x squared, so therefore 8 over 1.5 is x squared, so therefore x is 4 root 3 over 3. There we go. So this is not the maximum or minimum value of v, this is just the value of x that generates the maximum or minimum value of v. So now all I need to do is substitute this back into this equation. So on my calculator I've got 4 root 3 over 3, so I'm just going to do 8 answer, take away 0.5 answer cubed, and I am getting 64 root 3 over 9, which is, or 12.31. Okay, so how can I justify that this is a maximum? Okay, so what I'm going to do is if dv by dx, sorry there's not much space here, is 8 minus 1.5x squared, I'm going to work out my d squared v dx squared, and so I'm going to take the second derivative, and that is going to be minus 3x. Okay, so what is the value of x? Well, it's going to be minus 3 times 4 root 3 over 3. So that's going to, so therefore d squared v dx squared is going to be, so the 3 will cancel with the 3, so it's going to be minus 4 root 3, which is negative, so therefore it's going to be a maximum since the second derivative is negative. If it had been positive, that would be a minimum value, but it's negative, so it's a maximum.